Hi, it's 1T, and in this video I'll be going over the test 1 review. So let's go ahead and get started. So on number 1, you're solving equations. So I've been telling you about my CSI 1 and 2 step method. So basically we don't have to worry about fractions until we get to C. That's what the C stands for, clear fractions. So S is for simplify. Notice there's some simplifying we can do here. So we're going to multiply 4 times x, that's 4x, and 4 times minus 3. We're just using the distributive property there. And then the plus 5 comes down, and that's equal to 13. Now the left side is not simplified yet because we still have some constants we can combine. So we have 4x, and negative 12 and 5 will give you negative 7, so we'll write minus 7, and that's equal to 13. So now we've simplified everything we could. The I means isolate x on one side. Well, we already have x on one side. In fact, this is a two-step equation. So we will add 7 to both sides. It's going to take 2 steps to get x by itself. That's why I call it a two-step equation. These add up to 0. You're left with 4x on the left. On the right side you get 20, and so x is 5. So again, this one's a lot like the one we just did. We're going to be simplifying. There's no fractions to clear. So remember, in a case like this, you're distributing negative 1. It's 8 minus this binomial. So you distribute negative 1. And when you do that, all that's going to happen when you multiply by negative 1 is the sign changes. So the 8 is still here. Negative 1 times x is a negative 1x, so we'll write minus x. And negative 1 times negative 3 is positive 3. So again, notice the x became minus x, the minus 3 became a plus 3. On the other side, we'll also distribute, but here we're distributing 3. So this is 12x plus 6. Now we're not done simplifying. We still have the 8 and 3 that can be combined. This is 11 minus x is equal to 12x plus 6. So if you look at each side, on the left, there's no like terms. This is all simplified. Same thing on the right. So we're ready to move on to the next step. Now, excuse me, the I means isolate x on one side if you need to. Notice x is on both sides, and so we do need to isolate x on one side. So we could subtract 12x on both sides, and that would get rid of the x over here. Or we could add x to both sides, and that's what I'm going to choose to do. Either way will work. And so these add up to 0. You're left with 11 is equal to 13x plus 6. Again, this is a two-step equation. Once you've done these 3 steps, you should always have a 2-step or 1-step equation. So you're going to want to subtract 6 next. Get 5 is equal to 13x. We'll divide by 13. Again, we're trying to get x by itself. You end up with 5 over 13. All right, now on the last one here, we do have a fraction to clear, and we learned the way you get rid of a fraction, or I'm sorry, the way you clear fractions is by multiplying by the LCD of the denominators. Well, there's only one denominator here, so it's pretty easy to know what your LCD is. It's just that denominator, 4. So if you multiply each side by 4, so basically we're multiplying this whole side by 4, you would have to distribute the 4. I just like to go ahead and multiply each term by 4 on both sides of the equation. And so 4 times 3/4, you should get 3x. If you want, you could do your work like this. 4 over 1 times 3 over 4. That's 12 over 4 when you multiply across, which is 3. And don't forget the x. 4 times a fourth is 1, so this will be minus 1. On the other side, you get 20. And so the other thing I would mention is you can also use your calculator to check yourself and see, 4 times a fourth is 1, and so on. So this is a two-step equation, so we're done. We don't have any other steps to do, no simplifying or isolating. We'll just solve this two-step equation. These add up to 0. You get 3x equals 21, and so x is 7. All right, let's move on to number 2. Now, these are what we call compound inequalities, and in both cases, we're going to solve these two inequalities separately, and we'll put our answer, or we'll put and in between those two. Here, we'll solve these two separately, and we'll put the word or in between. This one will have a little more work to do than that. So here, I would subtract 7 on both sides. This is just like solving a two-step equation. And so these add up to 0. You're left with 3x is greater than or equal to negative 3. We'll divide both sides by 3. We get x is greater or equal to negative 1. Notice I never reverse the symbol because we never divided by a negative. If you multiply or divide both sides by a negative, that's when you flip the symbol. Here, again, it's a two-step inequality. We'll subtract 5 on both sides. We end up with negative 2x is greater than negative 4. Now this time we have to divide by a negative number, negative 2. So I'm going to circle that inequality sign. This becomes x is less than, and negative 4 divided by negative 2 is 2. And again, I'll put the word and in between. So we're supposed to give the answer in set notation, so this is set notation. And we also have to put it in interval notation. Now, really, we should write this another way. We can put x, anytime we have the and case, we should be able to combine these together into one statement. Certainly x is less than 2. On the other side, we'll have the smaller number, negative 1. This says x is greater or equal to negative 1. And so if you read that part backwards, it says x is greater or equal to negative 1 and less than 2. So x is greater or equal to negative 1 and x is less than 2. Another way to say that is it's between negative 1 and 2. So in interval notation, you would write this, well, first of all, let's go ahead and just draw a sketch, a number line. From negative 1 to 2. Notice here we're including the negative 1 because we have x is greater or equal to negative 1. Here we're less than 2. There's no equal symbol, so we'll use a parenthesis. And so this is what our solution looks like on a number line. And we would write that in interval notation as negative 1 to 2. So when you solve an and compound inequality, this is the kind of answer that we normally get. In our course, I've limited it to those. There are some special cases where sometimes you'll see some things different, but you're only going to see answers like this with the and inequalities that we do. All right, let's go ahead and do the or case. If you haven't at least tried it, you should try to do that. Put your answer with the word or in the middle once you're done, and then also see if you can write it in interval notation. So I'll go ahead and do it now, and stop the video if you want to try it. So here we're going to want to add 5 to both sides. You get x is less than 1. This is a two-step inequality, so we'll add 7 to both sides. Get 2x is greater or equal to 10, or x is greater or equal to 5. Just divide both sides by 2. Of course, 2 times 5 is 10. So our answer is x is less than 1, or x is greater or equal to 5. With an or statement, you can't combine it together into one statement like we did here. The reason why is there is no number that's greater than 1 and also at the same time, less than 1, and also at the same time greater than 5. You're either less than 1 or you're greater than 5, but you can't be both. So if you were to draw this on the number line, or graph it, it would look like this. Those are the values greater or equal to 5. Here you're going to use parentheses. These are the values less than 1. So interval notation is always written from left to right. So on the left, this goes forever left. So we start at negative infinity, and then up to 1, and we'll have a parenthesis. And then we'll use the union symbol, which is the same as using or, has the same basic meaning. And then we have 5 to positive infinity. And so that's how you would write that in interval notation. This is how you would write it in set notation. All right, let's move on to number 3. So what we've learned is, in a case like this, notice there's 3 parts. It's not like when you solve an equation where there's 2 sides, like this, if it were like this. And so we have to solve this inequality a little differently. We're not going to be able to get x on one side only. What we want to do is get x in the middle by itself. And so this is like solving a 2-step equation, except for there's 3 parts. So I need to get rid of the 3 first. I'll subtract 3 from all 3 parts. I get negative 10 is less than 2x is less than or equal to 5. We'll divide each part by 2. We get negative 5 is less than x is less than or equal to 5 over 2. And in interval notation, now again, you can graph it if you want first. I'll just go ahead and do that. So let's see, we have negative 5 over here. We have 5/2 over here. On this side, we're not including negative 5, so we'll have a parenthesis. These are the numbers greater than negative 5, which is basically what we need there. Basically, this is saying x is between negative 5 and 5/2. Notice the equal sign here tells me that x is less than or equal to 5/2, so this will be a bracket. So we're including 5/2 in our set. And it looks like this. In interval notation, we would write negative infinity to 5/2, parenthesis here, and bracket here. All right, let's move to the next page. Looks like I'm going to have to make 2 videos here. I try not to go longer than 20 minutes. And I don't think I can get all 3 pages done here. So I think we'll do this section here, and then we'll do a separate video for the next half. Okay, so with absolute value, excuse me, I think what I want to do is, let me get a piece of paper. There's 3 cases. If you have the absolute value of x equal to a number, we'll say like 3, then you know the absolute value of a number is 3 only if that number inside here is 3 or negative 3. So our first step is to write x equals negative 3 or x equals 3. Now if this were some other expression like maybe 2x plus 5, then this would say 2x plus 5 equals negative 3 or 2x plus 5 equals 3. What if we have the absolute value of x is less than 3? Well, basically what we're saying here is the distance from 0 to x is less than 3 units. So I'm looking for the numbers on here that are less than 3 away from 0. Well, that would be all of these numbers here. So basically x is in here between negative 3 and 3, because all of these numbers have a distance from 0 that's less than 3. That's what absolute value means. The distance from x to 0, that's what absolute value is. Whoops. And so the first step is to put x between 3 and its opposite. So if I'm solving, maybe if this was again 2x plus 5, then I would say 2x plus 5 is between -3 and 3. All right, the last case is if we had the absolute value, we'll say x is greater or equal to 3. So the picture looks very similar to the one up above. So the distance from x to 0 is greater or equal to 3. So what numbers have a distance that's more than 3 from 0 or equal to 3? Well, that would be these numbers out here. So x is either over here. Because of the equal sign, notice I'm using a bracket, or it's over here. So we would say x is less than -3, less than or equal to -3, or x is greater or equal to 3. So if you had something in here other than x, like 2x plus 5, you would say 2x plus 5 is less than or equal to -3, or 2x plus 5 is greater or equal to 3, and you would solve those two equations or inequalities. All right, so now we're ready to do number 4. So first, this is the first case we talked about. Whatever's in here has to either be 5 or -5. So we have two cases, 2x minus 3 equals -5, or 2x minus 3 equals +5. So we're going to get two answers. I'm going to add 3 to both sides. I'm going to do it here too. I might as well. It's almost the same equation. We end up with 2x equals -2. So x is -1. Over here we end up with 2x equals 8. So x equals 4. So normally we write our solution this way. It's -1, 4. The solution set is -1, 4. There's two answers, and so that's how we write that. So over here, this is the greater than or equal case, which, where did I put that? Did I throw it away? Oh, there it is. That's this case here. And so we're going to take whatever's in here, and we're going to set it less than or equal to the opposite of this number, the negative, and then the other and then the other part will say whatever's in here is greater or equal to 3. So in our case, we have 4x plus 5. So I always say write the 4x plus 5 greater or equal to 17. That's one of your two inequalities. The other one is 4x plus 5 is less than or equal, change the symbol, and change the sign of the number. So with a greater than problem, with inequalities, or a greater than inequality, your first step is to write this statement here. So whatever's in here, actually you can write it just like it looks there. That's the first case. Notice no absolute value now. And then the other case is when whatever's in here is less than or equal, so change the symbol, and also change the sign of the 17. So let's go ahead and solve this. We'll subtract 5 on both sides. In fact, I'm going to do that here too. And so we end up with 4x is less than or equal to -22. Here we're going to end up with 4x is greater or equal to 12. We'll divide both sides by 4 here. We get x is less than or equal to, now this is a fraction, you can reduce this to -11/2. If you said -5.5, that would be okay. And then here you're going to get x is less or greater or equal to 3. We'll put an or in between, and so that's our solution written in set notation. Now we also need to write it in interval notation. If it helps, you can graph it first. So greater or equal to 3, that's the numbers over here. Less than or equal to negative 11 halves, that's the numbers over here. So basically we're saying our solutions to this absolute value inequality are numbers over here or numbers that are over here. In interval notation, we start on the left, negative infinity to negative 11 halves, union 3 to infinity. All right, we're going to go ahead and break, or let's say I should do this one last one real quick. So I sometimes call this the OR case, because notice we ended up writing an OR statement for our first line, our first step. And this is the AND case. So when you have less than or equal or less than, you're going to have the AND case. If we go back to what we looked at before, remember with the AND case, we ended up, again, I call it the between case. You end up putting x between 3 and the opposite of 3. Because there's no equal symbol here, there won't be equal symbols on these. So let's go back to our problem. We're going to put 2x minus 6 between 8 and negative 8. And so now we want to get x by itself in the middle. So first I'm going to want to add 6 to each part. I get negative 2 is less than or equal to 2x is less than or equal to 14. We'll divide by 2. Get negative 1 is less than or equal to x is less than or equal to 7. So we're going from negative 1 to 7 with a less than or equal symbol. So basically we're going to do brackets because we're including the endpoints. All right, so we'll stop the video now and we'll have a second part. Whoops, where is my...